talked about our exponential functions in the previous section. Now yesterday we started talking about logs. Today we're going to start solving log equations. And we'll spend a couple days on this. So let's take a look at an equation like this. If I asked you to solve this, it's really hard to do when it's written in logarithm form. Okay, we just really don't know where to begin. But we talked about yesterday, if you have a log, how can we rewrite it? It's an exponential. So if I change this around, this means 3 to the second power equals 4x minus 7. And this is something I can solve. What is 4 to the second, or sorry, 3 to the second power? So if I add over my 7, divided by 4, we get x to be 4. One thing we do have to do on these problems is check. In a log, both the base and the argument have to be positive numbers. The only place you can have a negative is in what it's equal to. So when I say check, all you really have to verify is if I plug a 4 in here, is that positive? 4x minus 7 would be positive, so it's okay. So my answer is 4. So what would I have to do here? Write it in exponential form. So that tells me x to the second power is equal to 64. If I am trying to solve for x, how do I get rid of a square? And anytime you add a square root, what do you have to put with it? So I get x to be plus and minus 8. Make sure you check. The argument's positive, that's no problem. The base also has to be positive. Can my base be a negative 8 then? No. So my only answer is positive 8. Try some more. So how would I write this one? What does a negative 2 power mean? Negative, we take it down to the bottom. So x to the negative 2 is the same as 1 over x squared. How would we solve this? Okay. You can multiply by the reciprocal, you can cross multiply. X squared is 9 over 16. Square root, plus and minus, so we get plus and minus 3/4. Remember, we check. I don't want you to just automatically assume that x can only be a positive number, because I could have very easily had like the opposite of x is my base here. Okay, so you always have to just look back in the context of this problem. 16 over 9 is positive no matter what, but my base also has to be positive. So 3/4 is the only answer that will work here.
And so how do you check it?
You're just verifying with a log, the base and the argument both have to be greater than 0. So you're just checking if I put in 3/4, that's fine. But if I put in -3/4, my base would be a negative number, and that's not okay.
So you can never have a negative.
Right. For your base and argument.
Okay.
Let's look at B. What would I do here? I just have to evaluate that. The 3/4 means the 4th root of 16 cubed. You can use your calculator, or you just might know what is the 4th root of 16. Yeah, you cubed first. I was doing 4th root first. That's 2. So we get 8. Which one?
Huh?
Check. When I look back at this log, my base is positive. This argument has to be positive. So if I plug in an 8, that's not a problem. So x is equal to 8. All right. Okay, another. So if I said log base 36 of the square root of 6 equals x, how do I write that in exponential form? So this problem, we had these last week. How do we solve these? Same base. What would I change 36 to? And a square root is like what power? 6 to the 2x is equal to 6 to the 1/2. Once you have the same base on each side, you can just set the exponents equal to one another. So 2x equals 1/2. Divide by 2. And x is 1/2. Can you guys try a couple? So 3 squared is 9, x is 9. Quick check, argument's positive, so that's perfect. B, how do you have to write that? Okay. What is 2 to the 3rd? So if I subtract my 1, divide by 2, I get x to be 7 halves. Have to check if I put 7 halves in here. Is 2 times 7 halves plus 1 a positive number? Yes. What would I do if it were negative? The solution. Yep. All right. That's what the majority, pretty much all of tonight's homework is. Do we need some more problems like this? Okay. The other thing I want to start talking about. Tomorrow we are going to work a lot with the properties of logarithms. So first I'm going to put a slide up here, and I just need you guys to write all this down. I'll talk about it once you have it written down, but you need it in your notes so we have all of our properties. So the first things are just the stipulations. That's up to you if you want to write it down. If we're dealing with logs, the arguments and base have to be positive. That's all that's saying. The big things I need you to write down. Are the product, quotient, and power properties. So this is telling us how we can break logs apart. If you have the log of two things being multiplied, you can break it apart and add the individual logs. Okay, this has to do with, we know the answer to a log is an exponent, right? It's giving us an exponent. So if you think about exponent rules, if I said 2 to the third times 2 to the fourth, what do you do with those exponents? You add them. So if you have the log of things being multiplied, you add the individual logs. Think about exponent rules. If I have the log of things being divided, what do you do to the exponents? Subtract them. So if things are being divided, you subtract the logs. Make sure the one from the denominator is the one that's being subtracted off, top minus bottom. The power property is saying if you have log of something to a power, it actually brings that power down in front. That has to do with exponent rules as well. We know a power to a power, we multiply. So that's what's happening here. This is an exponent to another exponent, so you end up multiplying that. So these are all because of our exponent rules. A couple other things we've already talked about or we've seen happen. If you have log base a of 1, that's always equal to 0. Log base a of a is equal to 1. You don't have to memorize that. If you have it come up, you can figure it out. If I say log base 2 of 1, that means 2 to what power would equal 1? 0. If I say log base 2 of 2, that's saying 2 to what power is 2? 1. So that's why it works. I'm going to do a couple problems today with some more of the basic results from this, and then we will pick up with the properties tomorrow. So if I ask you to evaluate this, you might be able to do the first one, but it's asking me 8 to what power is 2? 8 to what power is 4? That's tricky because they're fraction powers, right? But if we use our property of logs, if I have the log of two things being added, so I have this, I could rewrite it as one log with those things multiplied together. So that's the same thing as saying log base 8 of 8. 8 to what power equals 8? 1. If I look at B, I have no idea 6 to what power equals 18. But I have two logs being subtracted. What can I do? Divide. And it's just log base 6, 18 divided by 3. Or log base 6 of 6. So 6 to what power equals 6? 1. So we can use this property to simplify problems. These are two more properties that we need to add to our list. I'll let you write them down and then I'll talk about them. Okay. So, a couple different ways you could think about this. We discovered yesterday that the log and the exponential are inverses of one another. If you do a function and its inverse, we know from our last chapter that those cancel each other out. So if I have an exponent a and a log base a, those are inverses, so they undo each other. If I take both of those out, what am I left with? M. Another way to think about it, if I gave you an example with numbers. I said 3 to the log base 3 of 4 power, and I told you to evaluate that. Technically, this is an exponential, right? I have 3 to a power equals x. If I want to write my exponential as a logarithm, we start with log base 3 of x equals to log base 3 of 4. So then kind of like our exponent rule, if we have the same log on each side, we can drop it, and you just get that the x is 4. So if the base of the exponential and the log are the same, they will undo each other, and just give you that argument. This works in reverse as well. If you do the log and then the exponential, same thing happens. Same reasoning there. If I said log base 2 of 2 to the 5th and asked you to simplify that. We know from our previous properties that exponents can come down in front. So this is 5 times log base 2 of 2. 2 to what power equals 2? 1. And you just get the 5. So anytime you have the exponent and the base with the same arguments, those cancel out. So let's look at this. What's this equal to? 8. If you use your properties, 3 and the log base 3 just cancel. So we just get 8. So if you recognize those, it saves you a lot of time. Let's solve this equation. How would I solve this? There are a couple different ways of doing it. You could write 16 to the 1/3. If you use those properties, what happens to your 1/3? Moves to the front. Is everyone with me so far? So log base 4 of 16 means 4 to what power equals 16? 2. So you get 2/3. That's using the properties. Could I have done this without that property? Yeah, you could have done it like the problems we were doing earlier. I said 4 to the x equals the cube root of 16. And gotten a common base. 4 to the x. Cube root is the 1/3 power. You know, get a common base, so 16 is 4 squared. And we get 2/3. So, it doesn't matter how, as long as you can get there. Any questions on that? Okay. Take a second and see if you can answer these two questions. So what's the first one? base of, an exponential with base of 2 and a log base 2 cancel. What's the second one? Log base 0.2 and exponential with base 0.2, cancel. All right. Let's do one final slide for today. This is what we're going to start with tomorrow. Using our properties to rewrite some expressions. If I ask you to expand, that is telling you to use your logs to break this apart. If I have the log of things being multiplied, how do we break that apart? They each get their own log. You have to write the base, so it's log base 7 of 8 plus log base 7 of 6. I didn't ask you to evaluate or get an answer here. It's just showing that we know what those properties mean. Make sure you're writing the base on your log. If there isn't a base written, it's actually assumed to be 10, so that's different than a log base 7. So base is required. How would I rewrite B? Okay. If I have log base 8 of the 4th root of r cubed, I could write that as r to what power? And then properties of logs, where does the power go? 3/4 log base a of r. Final one. Actually, can I do this one tomorrow? I'm going to stop here and do this one tomorrow. There is a handout posted. I want to make sure I give you enough time to work on that. So, the same handout that was posted yesterday, but you are doing day 2 of it. It's like 10 questions.